Last year you learned about the law of sines, which worked for any oblique, in other words, non-right triangle. And it said that if you knew the appropriate parts, then the sine of angle A over side A is going to be equal to the sine of angle B over side B is going to be equal to the sine of angle C over side C. So if we are working with triangle ABC and we know that angle A is equal to 32 degrees and angle B is 50 degrees and we know side C is 18.7, then the sine of 32 over A, side A, is equal to the sine of 50 over side B is equal to the sine of something over side C, 18.7. So we need to know that third angle. And we add 32 and 50 and we get 82, so 180 minus 82 will be 98 degrees. So the sine of 98 over 18.7. So solving for one of our sides, for example side B, we can cross multiply and say that the 18.7 times the sine of 50 is equal to B times the sine of 98. So to get B by itself, we'll divide by the sine of 98. And then we'll bring up our lovely calculator. And we're going to take 18.7 times the sine of 50, and we'll divide that by the sine of 98. And we get 14.465, so 14.5. All right, so side B is 14.5. Now we do the same with side A. So 18.7 times the sine of 32 will be equal to the sine of 98 times A. And so once again, we'll divide by the sine of 98. So this time we are taking 18.7 times the sine of 32, and we're dividing that by the sine of 98. And we find out that 10.0 is our side A. All right, so that works great. Now we also have a formula that we use to find the area of an oblique triangle. And that area of an oblique triangle comes from the fact that if you're working with a regular or an oblique triangle, we know that the area of any triangle is the 1/2 the base times the height. So in this case, my base is the side that's opposite angle A, which would be side A, and my height is the side that's opposite angle B, that's perpendicular from A, the altitude, to the base A. So let's go look at that. So we know that area equals 1/2 the base times the height. In this case, our base is A. So area is 1/2 A times the height. How do we find the height of this triangle? Well, we know if we know angle B and we know side C, then the side opposite angle B is our height, and the hypotenuse of this yellow triangle is C. And so the opposite over the hypotenuse requires us to use the sine of angle B equals h over C. So C times the sine of angle B is our height. So now modifying our formula, we have A equals 1/2 side A times side C times the sine of angle B. So that works for any obtuse or acute, any oblique triangle. A equals 1/2 AC sine B. So here's one version of that area formula. A second if you know angle A plus sides B and C, and a third if you know angle C plus sides A and B. So if we want to find the area of triangle ABC, and we know that angle C is 102 degrees, and we have sides B and A, we'll be using the formula A equals 1/2 AB sine angle C. So 1/2 of 90 times 52 times the sine of 102. All right, so bringing up our calculator again. We need 1/2 times 90 times 52 times the sine of 102. And we get 2,288.9. meters squared. All right, so we have a new formula for finding the area of an oblique triangle. We have our law of sines. Let's play with our law of sines again. This time we're going to be using a angle A, which is 29 degrees, see if I can get my ruler to come up here. It was working just fine a moment ago. There we go. An angle A, which is 29 degrees, a side A, which is 6, and a side B, which is 10. All right, so let's bring this down here a moment. And so we're going to start with angle A being 29 degrees. So we need a baseline. So we'll start with any old line segment. And then we need to create an angle that's 29 degrees. At that point A. All right, so we want this side B to be 10. So we'll get 1,000, 10 centimeters, 1,000 millimeters. So right in here, I'm pretty close. All right, so this is not going to be perfect, but that's okay. This is side A, 29 degrees. And side B is 10. And we know also side angle, or side A is 6. So we're going to try to eyeball this and see if we can get something that is about 6. 1, 2, 3, 4, 5, 6. We're close. We're going to go a little bit closer. All right, so from, this is not going to be perfect, from here to about here should be right at 6 centimeters. It's a little short, but right about 6 centimeters. So this will be side A. Okay, so let's work this out. That means that we know the sine of 29 over side A, angle A over side A, should be equal to the sine of angle B over side B. So now when we are trying to solve for the sine of B, we can simply multiply both sides by 10. And so we'll have 10 times the sine of 29 divided by 6 is equal to the sine of angle B. To get the angle B by itself, we're going to take the inverse sine of 10 times the sine of 29 divided by 6. That will give us plain old angle B. Alright, so here comes our calculator again. So inverse sine of 10 times the sine of 29 divided by 6 gives us a 53.9 degree angle. Okay, so now that we know that angle B down here is 53.9 degrees, we can add that to 29 degrees and then subtract it from 180. So we get 91.7 for angle C. Alright, so now we simply need to figure out what side C is. So the sine of 91.7 degrees over side C will be equal to, and let's use the original information we had, the sine of 29 over side A, which is 6. So to get the C by itself, we will need to take 6 times the sine of 91.7 and divide that by the sine of 29. Alright, so 6 sine 91.7 divided by sine of 29. Missed my dividing sign. Let's get rid of this. And we have our answer of 12.4. So this distance from here to here, side C, is 12.4. Alright, so that looks wonderful. However, we have a slight problem. Because do you remember when you were in geometry class and you learned that there were 5 ways that you could prove triangles congruent? You could prove they were congruent by side, 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 angle, side, hypotenuse, leg, angle, angle, side, and angle, side, angle. We were given an angle, a side, and a side, and so we never had a theorem that used angle, side, side, or side, side, angle. And the reason for that is because if we get our handy dandy ruler out here again, there's another triangle here that has 6 for its side. 1, 2, 3, 4, 5, 6. Alright, so we'll try to draw that triangle. We're really close to 6, not quite there, but it's a sketch. And so with this second triangle, should draw it in red or some other color. A is also 6. But angle B is no longer 53.9, and angle C is no longer 91.7, and side C is no longer 12.4. There are 2 triangles that satisfy this situation where A is 29 degrees, side A is 6, and side B is 10. And so, to find that other triangle, we have to realize that this triangle with the two angle B's, B and B prime if you want to call it that, is an isosceles triangle. So if this is 53.9 degrees, then the other base angle would be 53.9 degrees. And to find this angle, we would need to subtract 53.9 from 180 degrees. So 126.1. So we have this whole new triangle now where angle B is 126.1, and we can find our new our new angle C, which if we add our answer 126.1 to our initial 29 degrees, we get 155.1. If we take 180 minus that answer, we get 24.9. So our new angle C is 24.9 degrees. And then we can say, let's find our new side C. So side C will be equal to, if the sine of 24.9 is our angle C over side C, we can go back to our original sine of 29 over 6. To get C by itself, we will multiply 6 times the sine of 24.9 and divide that by the sine of 29, and that should give us side C. So we get 5.2. This is our second triangle. Now this only happens when you are given, two sides in the non-included angle. And it doesn't always happen. So this is called the ambiguous case in pre-calculus. And the ambiguous case says that when you're given two sides and the non-included angle, the height of that triangle is going to be b times the sine of a. And you get two situations or two solutions when that height is less than the side A, which is less than the side B. Okay, remember our height was b times the sine of angle A. So b times the sine of angle A is less than side A is less than side B. You see a pattern here? We found the height a moment ago when we were looking for the height of our triangle. And I see a B, an A, an A, a B. So b times the sine of angle A is less than side A is less than side B. Now there are situations where angle A is obtuse and you don't get a triangle. There's a situation where angle A is acute and you don't get a triangle. You don't so much have to worry about these conditions as much as you do just to remember this particular one, because the no solutions will, the no solutions will kind of work their way out. You'll get an error in your calculator or a situation where your angles are adding up to something larger than 180 degrees. All right, so we're going to check and see if these three triangles have two solutions or not. So looking at the first one, we want to know, here's our angle A, our side B, and our side A. So this is that side-side angle kind of issue. So we want to know, does B times the sine of angle A, is that less than side A, is that less than side B? So if I take 5 times the sine of 26, will that be less than 21? And will that be less than 5? Well, we don't even have to bother with this because 21 is certainly not less than 5. So this should have 0 or 1 solution. And we can work it out to find out whether it is 0 or 1 solution. But since A is greater than H, but A is greater than B, it will have 1 solution. Here's our second problem, so let's try it again. Is 5 times the sine of 58 less than, so B times the sine of A, less than A, 4.5, less than B, 5. This has potential, right? So we could potentially have 2 triangles here. So let's check it out. What is 5 times the sine of 58? We get 4.2. So is 4.2 less than 4.5 less than 5? Yes. So there are 2 triangles. In our third situation, we've changed the letters now, but the same process is going to hold. We want to know if, so here's our C and here's our side C, they're going to be on opposite sides of each other, or close together, and the one that doesn't match is going to be on the outside. So is B times the sine of C less than C less than B? Is 5 times the sine of 78 less than 12 less than 5? And this is a no again. So no, we won't have 2 triangles. We don't have to worry about both cases. All right, so your worksheet today was designed in mind with being able to use a protractor, use a compass, or protractor and ruler to work these problems out. So at least the first 6, if you find that you can have more than 2 triangles, it's good to actually physically see them, work through them, and draw through and work them out, because it makes a huge difference if you can see why these triangles are doing what they're doing.